In this video, I will explain the calculation of the maximum stress at the bottom of the foundation. The calculation is performed according to the three situations. Now I'm making an interruption. This document will be placed in this website. This is my website. And please subscribe to my YouTube channel. I need support. And then continue. Here, R force is the force coming from the column. You see it's oblique, and this means that it's the resultant force of the normal force and the shear force coming from the column. And its vertical component is RV. CL is the center line of the column. The width or the breadth of the, CL is the center line of the foundation. The breadth or the width of the foundation is denoted here with the letter B, capital B. And the eccentricity between the RV and center line is given here with E. If the vertical component of R acts in the middle third portion of the foundation width, we use these formulas to calculate the maximum and minimum stresses developed at the bottom of the foundation. If it's in the border, if RV is in the border of the 1/3 portion of the foundation width, we use these formulas, and it is outside of the 1/3 of the middle portion of the foundation width, we use these formulas to calculate the maximum stress, which is important for us because we will compare the maximum stress developed at the bottom of the foundation with the corresponding soil bearing strength, which is also a type of normal stress. Now we have a numerical example here. Calculate the maximum and minimum stresses developed at the bottom of the foundation given below. And the formulas are for the unit length of the foundation. The length is measured perpendicular to the page plane, perpendicular to B, and it's 1 because it has the unit value. So R and RV has Newton per meter or kilonewton per meter if you use the metric unit system. Here, R is given as 60 kilonewton per meter. And very easy calculation here. You understand that the magnitude of the vertical component of the R is 30 kilonewton per meter. The width of the 1/3 of the foundation width is B over 3, which is 4 meters divided by 3, results in 1.33 meters. And not the E, this distance, this length is compared with the length such that let me make a drawing here. This here is B over 3. This is the center line. So if your load is acting here, we have to compare B over 6, half of B over 3, with E. But if we consider B over 3, we have to make the comparison between B over 3 and this length. And this length is 2 times the eccentricity. So eccentricity value is here 0.5 meters, is multiplied by 2, and it's 1 meter. As you see here, 1.32 meters is greater than 1 meter. So our load coming from the column is inside the 1/3 portion of the foundation breadth. That's why we use these formulas. And the condition is here where the minimum stress is not 0. Then by employing those formulas, the maximum stress is calculated from this equation. You see the value of RV is 30 kilonewton per meter divided by B, which is 4 meters, and E is 0.5 meters, B is 4 meters, the foundation width. We obtain the maximum stress. And the minimum stress is similarly obtained from this equation. And then what we do as a civil engineer, we will compare this stress value with the corresponding soil strength, soil bearing strength, which can be calculated using some parameters which are obtained from easy soil test, or which is directly can be obtained from the SPT, standard penetration test. Now please to support me, subscribe to my YouTube channel. This document will be downloaded from this page. I will put it later in a week. Thank you very much.